Okay, so this is a skill we have talked about in Year 11 methods, and that's where we cover it. And for what we're going to talk about today, so that's going to be C and D, we will use our calculator to support us. But this kind of function here is called a reciprocal function. It has this form, y equals k on x, and it's inverse proportion, right? We were in 11 methods, we right at the start of the semester, we talked about a linear relationship. This is an inverse relationship because y is inversely proportional to x. So it has this form, all right, which means if I multiply both sides by x, I would have x times y equals k. So we can determine the value of k just by multiplying the x and the y coordinates together. So in this circumstance, minus 9 times 4, minus 36. And so this function is minus 36 on top of x. A couple of things to point out is that this function is what we're going to call a self-inverse. And we'll prove why that's the case in the second question. Prove that y equals k on x is self-inverse. So here's our second one. If we have f of x is y, which is k on top of x, that's the form that a reciprocal function takes. Now, in order to find the inverse function, we're going to use variable interchange. Okay, so if we're using variable interchange, then f minus 1 of x, the inverse function, remember that's how we notate the inverse function, is going to equal x, which is equal to k on y. And then all we're doing to demonstrate the truth of it, the veracity, is we'll multiply both sides by y, which will give us yx equals k, and then we'll divide both sides by x, divided by x, divided by x, which would give us y is k on x. And so you see the inverse function is the same as the original function, and thus it is a self-inverse function. All right, one other way that we could solve this question is remember that f of minus 1 of x will equal x. Okay, that's a relationship there. All right, so let's stop there. We'll finish exercise 3C and then we'll come back and do 3D.